Hi, welcome back to the Earth Science Classroom. Today looking at plate tectonics playlist, looking at Lake Baikal, the geography and tectonics of this amazing lake. It's a rifting divergent section of the continent, or of the Eurasian plate, and it's in Asia, or more particularly it's in Russia. And looking at basically looking at the where it is, looking at why it's important to look at, why it's important, looking at the tectonics. So in this playlist we've been looking at different boundaries, active versus passive margins, different case studies like the East African Rift Valley zone or system, and this kind of connects in somewhat to that system as everything is connected. So the tectonics is a big part of it, looking at the orogenies that are associated with this rifting, and also the stable rock formations of the Cratons as well. All right, guys, thanks a lot. Join me for the video. So Lake Baikal is officially the deepest lake in the world. It is one of the oldest, if not the oldest lake. There's some debate on which one's the oldest, but it is extremely old, around 25 million years old. And it is right here on this map, right there. So this is Lake Baikal. Now, if you listen to this in America or Europe or maybe the Southern Hemisphere, maybe Argentina or Australia, Lake Baikal may seem the most desolate and most isolated place on the planet, besides like Antarctica. And you're pretty much right. I mean, it's right smack in Northeast Asia, right here. And it's part of Siberia. Now, Siberia is a very large area of Russia, right? Russia is the country. Siberia is the region. It's the territory, like, you know, in Canada that you split it into different territories and provinces. And Siberia is basically all of this area right here, if I was going to shade it in. So from the Ural Mountains all the way across, okay, it's going to shade it in, there we go. So this is still Russia over here. Russia is a huge country, spans a great large area. It's the largest country on the planet. And this is all Siberia. It's crazy. And then you're thinking, what's over this like dashed line over here? Well, that's European Russia, where you'll find Moscow is around here. I apologize for my map if it's not perfect or accurate. I do like to hand draw my maps, and obviously the country borders could be a little bit off somewhere, but I apologize if you are offended by the country borders in your particular country in this map. But Lake Baikal is literally in the middle of nowhere. There's a couple of small cities or towns dotted near it, but really it's very isolated. It's just north of the Mongolian border and in Siberia. So in terms of the geography, you can see by the map that, you know, it's a large lake, and you could see it when you pan out to include the whole of Asia. So you've got the Indian subcontinent here, you've got Southeast Asia with countries like Laos and Vietnam and Thailand, and the Philippines over here, so it's kind of Southeast Asia. Northeast Asia up here with the Korean Peninsula, North Korea, South Korea, and Japan, and obviously Russia, Mongolia, and you've got kind of Central Asia with these lots of the Stan countries, okay, Uzbekistan, Kyrgyzstan, Uzbekistan, Azerbaijan, all these, or Turkmenistan, all these Stan countries, and then you got the European section of Asia over here, which is like Georgia, Azerbaijan, and Armenia, and you see Turkey there as well. So I have also got the Middle East on this map with Iran and the UAE and Oman there, and we'll get to that later with our tectonics. But you have this large, huge continent of Asia, and Lake Baikal is literally in the middle of this huge landmass. All right? So besides the actual countries that are around the lake, you have other lakes pictured on this map. Now they're a lot larger, or basically, but you have these three mountains. You have the Aral Sea, which is decreasing very quickly in size, which is right here. You have the Caspian Sea, which is not really a sea, but they call it that, Caspian Sea. And then over here, we have the Black Sea, which is right there, this area right here. So I'm just going to color it or shade it in blue so you could see, where it is. So you've got, this is the Caspian Sea right here, okay, the Aral Sea right there, and the Black Sea, which kind of like is this part right here. Okay, so there's your inland seas, or inland lakes, and obviously Lake Baikal is right here. So you see a kind of a size comparison where Caspian Sea is a lot larger, the Black Sea obviously is connected to the Mediterranean, but the Aral Sea is also reducing in size every year. So the Lake Baikal is kind of by itself. Now there are some other small lakes around here that are all dotted around, but there's nothing of a substantial size compared to Lake Baikal, and as interesting as in geology as Lake Baikal as well. And in terms of other water bodies, you've got the seas, the Yellow and Sea of Japan, East China Sea, South China Sea, the Bay of Bengal, the Arabian Sea, the Gulf of Oman right here, and up here also is the Laptev Sea up here, northern Siberia. So you have all these border bodies, but the main lakes are listed right there. Now, me personally, I grew up in England and educated in England, went to uni in England, so I had a nice mixture of both the physical sciences and more of the geographical sciences. In terms of, the geography and the human aspect was always intertwined with the physical, Mother Nature aspect of Earth science. And so when we did a case study or did a investigation into something that was geological or physical, we'd always add in that aspect of countries and location and geography and a little bit of history as well, because that could also tie into the physical sciences. Now, in terms of tectonics, Asia is a fascinating place. It's a very large landmass, remnants of Pangaea and the break of Pangaea, where you had this large landmass together, broken up, and what you have is you have various plate boundaries. So in terms of the actual area, because we're doing such a large area, the plate boundaries are convergent. So you have some ocean to continental convergence over here, the Pacific, the Philippine plate with the Eurasian plate. You have the connection with the North American plate up here around Japan. You've got the India subcontinent converging into the Eurasian plate with continent hitting continent. You have the Arabian plate, which is a minor plate. It's going to converge into Eurasian plate. So you have these long stretching lines of convergence down here. Down here, this is the convergence right here. Okay, you've got the subduction zones and convergence here on the Western Pacific. Sorry. You have here some thrust faulting up here in Northeast Asia, and again through here, through Russia into Japan, you have some convergence. So, and here you have various thrust faults, various different transform faults right here, and also here through Central Asia as well. So you have varying amounts of these large major and minor tectonic plates that are converging and creating the surface processes, the subduction, the volcanism, the fold mountains, the orogeny, and also you have in orange down here in the bottom left corner and the top right corner, you have these orange lines. They represent our divergent plate boundary. So you have your seafloor spreading. Oh, seafloor spreading. You know what? I'm just going to erase that and do that again, because that was not English. There we go. That's better. And you have your ridge or your rise. So you have your two main convergent or divergent plate boundaries, and you have some transform plate boundaries in there as well, most notably around the Gulf of Oman and also into Gulf of Aden here with the linking up with the Triple Junction and the East African Rift Zone. But what I want to concentrate on today is a large area right here. This large area outlined by the red dashed lines right here, and it goes from eastern Turkey down into central China. It's huge. It's huge. It is called the Persia, Tibet, Burma orogeny. So right there, the orogeny, you know it's some sort of mountain building, some sort of increase in elevation due to generally convergence or some thrust faulting. So you have collision between generally two plates that are continental, similar density, and you do get this elevation increase over time, and you get the formation of plateaus and mountains and massifs and all that good stuff, and I have videos to review that as well. But this Persian, Tibetan, Burma orogeny is huge, spans thousands of miles. It includes various mountain ranges, like the Himalayan mountains, the Tibetan plateau right here, and the Altai mountains up here towards Lake Baikal. And this is kind of like the ongoing process. So you have these two subcontinents. You have the Arabian plate smashing this way. You have the Indian plate, which kind of started off breaking off from Africa and Antarctica during Pangaea and the breakup of Pangaea, and very slowly in the course of 16, 20 millimeters per year, moving up through across the Earth's surface through convection currents, and then eventually around 10 million years ago, the first impact was up here in the northern part of the collision zone, and then slowly worked down its way down to here towards where modern day Bangladesh is, and this part was the last to kind of like collide. So India collided with Eurasia, which is up here, the large Eurasian plate, and formed this huge orogeny, and it's continuous today. So the last 10 million years, it has been growing and producing this large orogeny, large elevated flatlands, elevated mountain ranges, and is still going today. So this is a consequence, this large yellow highlighted area, this Persia, Tibetan, Burma orogeny zone, this is a consequence of Arabian minor plate and the Indian subcontinent smashing in, colliding into Eurasia. And the size of it is the ongoing process, so it's getting bigger. Now, Lake Baikal, because this is our case study, Lake Baikal has a divergent plate boundary, a rift-in zone, an area where the plates are diverging, they are spreading, they are moving apart. And this causes a rift. This causes a bunch of what's called normal faults. So we have normal faults, which is tensional stress. Tensional stress pulling apart of the crust and lithosphere, and there would be some sort of asthenospheric diapair or elevated bubble or hotspot that could be forming underneath, or could be just from the collision of the orogeny or the formation of orogeny. But Lake Baikal is that area of rifting. Now, the next thing we will discuss, because we've already discussed the Persian, Tibetan, Burma orogeny, and the collision points and the convergence plate boundaries, and you've got this main Himalayan thrust zone as well, is you also have, because it's such a large continent, you have areas that are very stable, very old rock, and these are called Cratons. Now, in this case, which refers to Lake Baikal, we're looking at the Siberian Craton. Now, in a Craton, you have a platform or shield, and there's a video for that as well if you want to check it out. Difference between a Craton, a shield, and a platform, but they're all part of a Craton. Craton is a very large, stable body of rock that most continents are built around. There's one in North America called the Canadian Shield or Canadian Craton, and this one here is in Asia. So this Siberian Craton is huge, absolutely huge. Covers most of Siberia up into the Laptev Sea and kind of like curves around. So it's like a nice little, so this kind of area right here kind of like touches Lake Baikal right there and then comes off into this area in Northeast Asia. So this shaded area of blue is kind of like the Craton, and you'll see that Lake Baikal is just on the edge of this Siberian Craton, this very strong rock formation that is very hard to break down, especially with the breakup of Pangaea. It kind of stayed for billions of years. So Lake Baikal is located in a old Sochir zone, okay, which is a zone of two plates meeting. You'll find that around the Himalayas too, where India actually hits and collides with Asia or Eurasia. And this Sochir zone is an area of weakness, and it's right next to an area of strength, which is the Craton. So when you have this rifting effect, it's going to rift in an area of weak lithosphere, and this is why Lake Baikal is located on the side of the Craton and not in the center. Also, it is right on the edge of the Persia, Tibetan, Burma orogeny. So it's smack in between two large systems, a strong, stable Craton and a ongoing, ever-growing orogeny in this Central and Southern Asia. Now, there's different plates as well at work. So we take the Lake Baikal rift zone. This means that there is one landmass, okay, one's going that way, one's going that way, and what we get is the lake that's in between, and that's why it's so deep. So, because there's rifting, you get the separation of two landmasses. You've got Eurasia on one side, which is this large, basically super plate, Eurasia, okay, which is very stable. And you've got these smaller minor plates and microplates that break off around the edges due to various processes, rifting or just orogeny as well. So you have the Amur plate, or the Amurian plate, which is kind of like the Chinese plate, the northern Chinese plate, right here, which is a microplate, kind of breaking off, and this is going this way. All right, and the orogeny also is going to kind of like intentionally push that way. Eurasian plate is going this way, but very, very slowly. Most of the movement in this Lake Baikal rift zone is going towards the east, like this. That's the majority of the direction as shown by seismic testing in the area and GPS. So you've got the Amur plate there. You'll have down here you have the Yangtze plate. Which is covering most of eastern China. And down here you have the Sundra plate down here. So, and over here also you have the Obelix plate. Sorry if I've mispronounced that. So around the eastern side of Eurasia, eastern part of Asia, you have these smaller micro or minor plates that are kind of breaking off or separated from the main Eurasian plate, basically caused by in between major plates, the Eurasian, the Pacific, the North American, and these smaller plates are going to arrange themselves in between areas of weakness in the lithosphere and break off, especially with the Amur plate and Eurasian plate causing the rifting at the Lake Baikal rift zone. All right, so that's kind of the geography and major tectonics of this area, kind of a broad view on Asia, looking at how Lake Baikal, where it is located and how it is possibly formed. In the next video, part 2, I'm going to discuss the formation, different types of theories that are put forward by scientists of how it's formed, the different geology, and some facts about the lake. All right, thanks everyone.